Well, we would like to thank, first of all, MCAA, NCMA, IMI, and BAC for their support also. It would not happen, BIM would not happen without them, and in addition to the other sponsors, we just want to express our appreciation for their commitment to BIM. Today, we'd like to answer the following questions. What is the database? And if you want to switch to the next, there you go, one more. What is the database? Why do we need the database? What are the, excuse me, who are the stakeholders? What is the database, or what's in it? How will this testing go on, this trial implementation? We'll want to do a critical review by the suppliers. We'll need your help, and then we'll wrap up today. So we'll go to the next. First thing, our first goal is to create a marketing program. We need to compete with concrete, steel, glass, and wood structures, and that was something that as we looked over our industry, we felt that that was really lacking. I think, as all of you suppliers know, we and manufacturers, we have not been a very well integrated group, and we felt like to compete with these other large industries, we needed to create a bigger marketing program. We also needed to create multidimensional software programs to aid design and construction of masonry systems for architects, engineers, mason contractors, and general contractors. We need to be able to reduce the scope of the project by making things easier to get access to the schedule. We wanted to be able to reduce that, get material on time, and we felt like that budget was another issue that we were going to struggle with in competing, so we wanted to be able to find a way to compete with much more precise information for costs, materials, labor. We wanted to be able to figure a better budget for our schedule and so on. And then we felt like to do this, we needed to develop an industry database to manage our data. And that's what I think most people, most manufacturers think that this BIM was all about, was to create a database. But that was a very small portion of that. We want to get into that in just a second. Next. When you look at this detail here, this wall section, and you start considering all of the many parts and pieces that make up that wall, the reinforcing, the flashing, the insulation, the wall ties, the drainage systems that go into it, weeps and flashings and other. You look at window connections, and you're looking at backup systems and what goes into the backup. You're looking at engineering, how it's designed. You're looking at mechanical and electrical and plumbing, sometimes connecting to and sometimes passing through this wall system. Now consider, how are each of those items specified? What are the features of each of those individual products? How are they ordered? How are they scheduled? How are they procured? Who's doing that? How is it installed? What goes first? What goes second? What goes third? What's the life of each of these individual pieces? Do they all have the same life? When we're talking about cradle to grave, if we build a building with one material that has a 100-year life, does that make all of the components 100-year life materials? And if not, then we need to look at how do we maintain them. So as you start looking at each individual piece of this wall, and then this wall becomes part of a bigger section. Next. Here you can see we start out with the owner looking for a project. There may be a web application that gets him some information into this Masonry Unit Model Database. So he may be looking at what kinds of products are available, whether it's a thin brick, thin veneer system, is it a cavity wall system, is it a structural system that he's looking at. Then they have access to this Masonry Unit Database to find materials that match what they're trying to accomplish. The architect and engineer, and not just structural, but all engineers, have the ability to take a look at this Masonry Unit Database. What are the products that I'm considering? What are the strength characteristics? What are the durability characteristics of the individual products? And somehow they need to be able to access that. Is that local? Is it a local supplier? Is it regional? Is it national? If I design in Seattle on a project in Florida, is that material available? What specifications? What building codes? All of those questions need to be answered, and we look to this Masonry Unit Database model to help us with that. The mason or general contractor is looking to, specifically the mason, can also go to the web and look at individual pieces of product that match what he's required to construct. What's the compressive strength, possibly? What is the life or the durability? What's the length? Maybe he's considering cost savings by going to a different size. And so those issues would be available from this Masonry Unit Database, as well as the general contractor and maybe back to the owner again on maintenance. What products should I use to clean? What products are compatible for replacement? What is the life cycle of caulking of this particular product, and so on. Then we go to this AEC team that has to manage and track and build a database and make sure that everything's consistent. There needs to be this flow of information that is in the right columns and rows so that the engineer, architect, the software manufacturer all know where to go to get the data, and it's all consistent from one manufacturer to the next manufacturer. Next. Masonry materials, as you see here, there's some other product issues that we want to consider. Size of material. What's the system? Is it a thin brick or a thin veneer? Is it a masonry over steel stud, wood stud? Is it over CMU? Is it over concrete? Then the different colors that are available from every manufacturer. Then there's the sizes, from thin veneers all the way up to the largest materials manufactured. Then we go to the different colors and textures in each of those products. So just looking at our masonry materials that are manufactured by the concrete, the clay, and the cast stone groups, we have lots of other material issues that we are looking at, and we need to certainly meet certain specifications, comply with certain requirements. So this just shows you really kind of the initial complexity just of these little individual pieces. Next. So here we start with a database, and this is a multi-level. This is only one page, but here we maybe start with the size of a product. So I started with a 2 1/4 modular brick, and then we start looking at possibly, maybe a JPEG or a BIM three-dimensional model that's going to be attached to this. We would also have the issues about availability. We'd look at compressive strengths. We'll look at cold water absorptions if it's clay or concrete, or shrinkage, expansion. All those issues will go into here, and then behind this table there would be one for every different color or every product. And so we can start adding pages to this database, so it's no longer two-dimensional and just a single page, but it's now multi-dimensional with multiple pages that we need to consider, and every one of these will help us make decisions. Maybe there's a certain grout type that goes with a certain type of prism strength for a given unit for a given manufacturer. So we start looking at this, and again, the database now becomes extremely large, and there will be certain manufacturers that won't want to compete in certain arenas, and so regionally they may say, yes, this is available, or no, this is not available. And we want to continue looking at more what you want us to look at, and this is where this, as manufacturers, we need to be involved in this process so that we are supplying to the architect and the engineering community those elements that will help us to produce the product, that will allow us to produce products that we make, not products that we can't make. It will keep a consistent database so that everywhere you would supply materials, they would be consistent. So if I'm in Wisconsin and there are certain requirements there that are different from those in Texas, the regional information could stay and tie to whatever region we're looking at. Next. Now we add this to the building. And you can see when we start looking at the building, now we look at, are there shear walls? Do we need deflection characteristics? We need to be able to look at the width and height and length and how they mix into this wall. And then we start looking at, are there accent bands? Are there texture bands? Are there size changes that are going on? Do we have shapes at window sills and around windows? Do we have a special shape at a wainscot? Are there trims that go around windows that are made out of a different material? And then we start looking at slotting and textures that maybe this computer model initially would look at it as just a sheet of paint, but now we want this computer model to be able to tell us at the end of the day how many units are there of each piece. Is there interference between our materials and some other material? And can we address those and deal with those? So this is where we start. This is, as you can see, it starts to blow up rather quickly. And Russell, I'll turn it over to you.
Thank you, Jeff. From here at Georgia Tech today, I'm Russell Gentry. I'm on the architecture faculty here at Georgia Tech and leading the BIM-M Masonry Unit Database project. I love it that Linda was calling it the MUD project. I guess there's a certain reason to call it that. My colleague Chuck Eastman, the director of the Digital Building Lab, is with us also today, and Shani Sharif, who's a PhD student here in the School of Architecture. I also just want to acknowledge the support of the Charles Pagnow Foundation and Mark Pernicone, who manages the projects that we have from BIM-M, and he's a great supporter of the project, as well as the four primary industry trade associations who are funding us. So we want to answer some questions about the database. Jeff's done a great job of getting us started, but and motivating us as to why we need a unit database. And I think in the big picture, if we can't have a geometric database of the masonry shapes, then we can't build models of masonry walls, which are the building blocks of masonry buildings. And so in phase 2 of the BIM-M project, which we're in now, we're working our way up the food chain from units to walls to masonry buildings. And so that's why we're starting with the Masonry Unit Database. And architects and engineers and contractors draw masonry units and then draw very complicated models often when they're trying to figure out geometry. And we need to provide them that geometry in a standard formats in a reliable way. And we have looked at what's out there in terms of masonry unit models provided by many of you who are supplying masonry units. And it's a bit ad hoc now, if you will. That is to say that the information is provided in a not a standard way across the industry. And in addition, engineers and architects need more than just geometric information. There's other specific information about the masonry units regarding strength, thermal properties, cost, availability, that could also be part of the Masonry Unit Database. And finally, I think it's important to say that the Masonry Unit Database could act as a new channel for you to reach your clients. That is, that if all of the information is there in one source, it may be, you may find that new customers are coming to you because of the ability to reach out and get your data. Jeff showed this diagram earlier, and I think it points to how we ascertain, how we figure out what people need to know about the database, what they need to know, excuse me, about masonry units, and how they figure it out. So Shani is going to talk to you briefly about workflows and stakeholders in the masonry unit industry.
So in order to know what is the Masonry Unit Database, the first thing that we have to do is to define a data model. That with this data model, we can capture all the geometric and non-geometric information for the masonry units. These information will be later be used for selecting, specifying, and purchasing masonry units in different stages of the project. If you want to have an overview on the masonry unit, we can define two types of attributes that each masonry unit has. One type of attributes that I will call them the internal attributes. It defines attributes such as geometry, physical properties, color, material, and texture of the masonry unit. And we have a second set of attributes that is about who is dealing with these units, who is the manufacturer, who is the supplier of this unit, and in which project you're going to use these units. So a combination of this information is going to frame the data model of our Masonry Unit Database.
Good. And I think it's important to also talk about what the Masonry Unit Database is not. So we don't see the Masonry Unit Database having a lot of information about the availability or tracking orders or the shipping of masonry units. These are back-end processes that you are managing in your business. And we don't perceive the Masonry Unit Database as driving an e-commerce marketplace for masonry units. And that might be an important thing that the industry wants to consider, but that's not what we're doing. We're developing a database that primarily gives geometric and material property data to the architects and engineers. And the question has been raised, should the database consider information about price, or is that something you'd rather not have in an industry-wide database? That's not for us to decide here at Georgia Tech. That's for you to decide as an industry.
Looking at a masonry project in a big picture, from the very start, from the pre-design phase to the last phase when we have the build project, we can see different phases in this project and different stakeholders perform different tasks throughout this life cycle, and they interact with each other, and also they need different information about the masonry units. And so if you map out all these activities in a business process modeling kind of framework, that's what we have done in this slide. You can see there are different activities such as architectural material selection, the structural engineers, or the energy analyzers, the cost estimating, quantity takeoff. And if we zoom in one of these activities, for example, in this one, the structural engineer in the design development phase, they receive some BIM model from the architect, and in order to perform the analysis on this BIM model, they need to know some information about the masonry units in terms of geometry of the units, and also some aspect about the physical properties of these units that the architect has defined for this project. Having this information, then they can build their analysis model and do the analysis and return the result back to the architect and the other stakeholders in the project. And you can see these are the type of information that they do the query on the database based on their need in that specific phase of the project. If you want to classify in a detailed level different type of masonry units, we can say we have 4 major masonry types: the concrete masonry units, architectural brick, structural brick, and cast stone. All of these units, they have some properties that is somehow shared between them: the size, the nominal size, the actual size, the material type, number of cores, the texture, the color. They may vary between these different types, but in a big picture, we can classify them in certain groups in order to embed them in the database. And going back again to this diagram that we had the internal and external attributes for the geometry units, for the masonry units, we can translate that data to this picture, which can be a little bit confusing at this point, but this is a view of an entity relationship model for a database, for a relational database. Basically, this diagram is telling us this information, if we have the masonry unit, if we have the manufacturer, and if we have the supplier on the top of the picture, how they are relating to each other, and what are the specific attributes for each of, for example, what type of information we want from the manufacturer to embed in the database, what type of information for the texture or for the color we want to have in the database. And different groups that are involved in the project, either the engineers, architects, manufacturers, they can look at these attributes and see what they need and what is missing and add them in this diagram. We will discuss them one by one in the future slides. Jeff talked about these Excel kind of format for a database, but if you look at it in the big picture and think about managing the data and having different copies and how we are going to maintain the data, we can translate that to a relational database view of this model, which we assume that it's going to be kept in a central database that everyone, either the masonry manufacturers or the users of the data, like the architects, can have access to this information. So we won't have the problem, we won't have worry about different copies of the data, and everything is managed by one central kind of database. If we go look at the information one by one, if you look at the unit itself, there are some basic attributes that we want to define this unit with. It's the name of the unit that different manufacturer may give their masonry unit different names, and this is this place is the way that we define that one. We have the family name, we have the type of the unit, we specify if it's a CMU, it's a brick, or a cast stone. Is it a generic unit? Can we replace this one with another model easily or not? Do we have any EPD for this unit? And we also can associate the drawings and images that the manufacturer provide for this unit. In addition, you can see that we have a GUID for this unit. It's a global unique identifier, a type of identifier that says that this unit has a unique name in the database, so it's not going to be mixed with the other units. But this is a question for manufacturers. If you have any type of SKU or UPC for your product, we can easily swap the GUID with this unique identifier that you have, so we can maintain the uniqueness of the data globally somehow. If we go into detail in the other information that we need aside that basic data for the unit, we can start with the geometry of the unit. We can define a set of data that we call it the regular unit geometry, which is like the length, height, and the width of the unit. And also we can break that down into the CNU unit geometry, brick unit geometry, and in the future we will add the cast stone unit geometry and cut stone unit geometry.
So following on the description of geometry in the database, we have broken masonry units into 3 separate categories. The regular unit geometry can be represented parametrically in the database. And what I mean by that, I'll show you an example in a minute, but that we do not need to provide a drawing for the units, because just a tabular description of certain parameters allows us to generate the drawings of these units automatically through the parametric modeling software. The second category of masonry units are special units. That is, that they may have certain features that make the units a bit more complex, but you may pick a regular unit for the display of the unit geometrically in a BIM model. And finally, we know, especially, for example, in the cast stone industry or in some brick specials, as we often call them, there are custom masonry units whose geometry is simply too complex to store parametrically in the database. And these will have to be drawn by you, and those drawings will have to be uploaded as we instantiate the database. A regular unit can be thought of as primarily rectangular, a cubic, if you will, but with certain other features. And as Shani said, we have both kind of the standard regular unit geometry, which is ecumenical in terms of what material system it is, and then also specific parametric features which can be used to describe the wide range of shapes that are common in the clay and concrete masonry industries. And these are just tabular data that describe the geometry of the unit. And it's not only, these features are not only used to generate the drawings of the masonry units, but also in certain cases, for example, in structural engineering workflows, the structural engineer may need to know the face shell thickness or the web thickness, or the energy analyst may need that information. So all of that is extracted in tabular form and available in the database for those sorts of calculations. If we look at a regular masonry unit, when I talk about it being described parametrically, what you can see here is a standard kind of king brick. In this case, it's 3 5/8 by 10. So it's just a standard parametric shape. This shape was not drawn. This shape was generated from a table of attributes. And you can see parametrically, after I've generated the table from the database, I can change the attributes. I can make the brick 12 inches long, or I can make it 4 inches wide, and those drawings change automatically. So you can see the power of developing the shapes parametrically. It's a much more compact representation in a BIM model to represent the object like this than it is as a custom drawing. This software, by the way, you're seeing is called Autodesk Inventor. It's the parametric modeling software used by Autodesk, and it's kind of a feed-in to Revit. Here's a special unit. So this is just a 3-chord brick, and you can see in the pictures above that there's some geometry that's a little bit complex on this brick. The 3 cores aren't really round, they're a little bit D-shaped, and on the back side of the brick there's some scoring, the picture below shows the way that it would be represented geometrically in the database. And so what we would say that in terms of a BIM model, that lower representation is probably sufficient, and so we could just call that a special unit. Here's a custom unit. So we see some sort of corner, bullnose shape going around a corner, and that geometry is too complex for us to represent as parameters in a table. We just can't anticipate everything that you might want to do in terms of masonry. And so what we would imagine is that we're going to just store in the database what we call a bounding box, which is the outside 3 dimensions of the masonry unit, along with a 3D solid model of the unit if someone wants to bring it in and detail with it, etc. And when I use the word bounding box, a lot of BIM models, and I'll show you one in a second, a lot of these models, basically, you don't want to see all the complexity of the masonry unit in the BIM model. That may be unnecessary, too much detail. And so, in fact, we can represent the unit in a BIM model as just a cube. And in terms of storing information about that cube, we need to store some insertion points, either maybe the corner of the block, that's what I call insertion point out, or maybe at the bottom of the block at the center of the withe in which it's going to be inserted. Because remember that the masonry unit model is ultimately going to feed into a masonry wall model, and we have to know how to automatically insert these blocks into the masonry wall model. So we're going to store the bounding box and the insertion points of these masonry units. Shani talked about images that are stored along with the data, and these images will be linked to pictures that you take of your masonry units, both in this axonometric view, side view if you will, as well as straight on. And no matter how good a computer representation of the masonry units are, we know that masonry has colors and textures and uniqueness that can only really be understood if you can see pictures of it. So what we imagine is that we will provide guidance to you on how to take pictures of your masonry units. Most of you are familiar how to do this already, in a standard way so that they all look the same in the database. And finally, of course, we are going to be exporting geometry from the database into BIM models. And so we have to store these, either store or generate these CAD and BIM models of the masonry units as they're called for by the architect or engineer, whoever's doing the drawings. And so we have these 6 potential formats that we need to store in the database or link to from the database. So in some cases, architects still download 2D drawings of masonry units, either in plan or elevation. And then we have 3D models, the DWG and DXF formats from Autodesk. The Parasolid format is used by most parametric modeling. We have Revit family files. These are RVA files, which for elements that are imported into Revit, and IFC files for OpenBIM software. So in the future, we're going to be building IFCs, which are the data schema for OpenBIM applications for masonry walls, and so we'll need the IFCs for masonry units as well. And finally, we learned that many of you draw masonry walls in SketchUp. I would bet that the detail that was shown by Jeff Elder earlier in the presentation was a SketchUp drawing, and so a SketchUp component is necessary to bring into SketchUp if you're trying to draw masonry details in SketchUp. So clearly we need some input from a stakeholder community here, from architects and engineers, to make sure that we're putting the information in the database that they need. And we want to just remind you that since the Masonry Wall project is just getting started, we may have to go back to the Masonry unit and update it to make sure that the Masonry Wall definition and the Masonry unit definition work together. Just an example of the kinds of drawings that get produced by, in this case, mason contractors. This is from Adrian Siverson of R&D Masonry in Marysville, Washington. And these are shot drawings that he produces for this masonry contractor. And it includes both three-dimensional drawings of the masonry walls and backup systems, again in SketchUp, using the bounding box models of the masonry units. Notice it's not really necessary to present the cores or the frogs or anything like that in this sort of masonry model, as well as drawings, axonometric drawings of all the masonry units used on the job. So this is actually part of many mason contractors' current workflow to draw all of this stuff, and so we should be providing them the drawings necessary. So in addition to the geometric properties, we have a huge range of what I would call engineering properties that we have to store for the masonry units, including their compressive strength, their modulus elasticity, their density, their weight, right? All of that stuff needs to be stored in the database to support engineering analysis, takeoffs, etc. And we are already getting some good feedback from our architecture engineering community about what we do need and don't need in the database regarding concrete and clay masonry, but we've got some work to do to clean that up based on their comments. Also, in the database, we store information about the individual constituent materials that go into your masonry units, and what percentage, let's say, of Portland cement or coarse aggregate or fine aggregate. And that's not really so that somebody else can make your masonry unit, but you can think about it almost like an environmental product declaration or MSDS, material safety data sheet of your masonry unit. And the reason for that is many architects need to know about the constituent materials in your masonry units for LEED or other eco-scoring schemes, including, for example, what percentage of the material is recycled. So that the database accommodates that as well. Now, let's talk briefly about the aesthetic properties of masonry. Perhaps in a BIM model, it's not so necessary to represent color and texture, but if you'll remember from an earlier slide, we see the database also as a way of reaching architects, building owners about the possibilities of masonry, about the aesthetic characteristics of masonry, and so we have to represent that in the database somehow. And with texture we know is really complicated. So we've kind of we've considered an attribute called texture amplitude in the database. And so here's just a quick snapshot of a survey of masonry textures that we found from those of you in the concrete and clay masonry industries, and the kind of terms that you use to describe your textures. And so we have a texture amplitude between 1 and 10. That's an arbitrary range. And so 1 are the really smooth masonry units like ground face block or glazed clay masonry, all the way down to 10, which would represent highly figured faces, slumped faces. And I give you some examples here. And the reason this information would be stored like this in the database is the architect might want to search and say, show me some textured masonry. Show me some red bricks which have a combed face or a weathered face. Or maybe the architect is trying to look at different ground face or polished face blocks and said, show me all the blocks that have a texture amplitude of 1. Oh, I didn't realize I could get that. I like that a lot. So we need to store the information to support what I would call these fuzzy searches by architects and engineers. And what about ribs? So one of the interesting things is the combed unit that we see here in the figure is certainly considered a texture by us, but something we're wrestling with is whether the ribbed units should be treated as geometry or as a texture. You could actually create the ribs as parametric features on the block and show it in the BIM model. It's very tough to show texture on a BIM model. They tend to get very heavy, if you will, very complicated very quickly when you try to do that. We have the same sort of issues with color. Masonry units are available in a wide range of colors, and we use different names for the same color, and we also have ranges of color. Some masonry units are delivered with a very tight color band, if you will, and others are blends or have wide ranges of colors on the units, especially in the clay industry. And a question for you is, do we want the Masonry Unit Database to have color attributes? I think the answer is yes. But do we want the Masonry Unit Database to support photorealistic rendering? And if so, then we have to store certain information in the database to support that. And we're not sure about that yet. You're probably all familiar with the Masonry Designer software, and that software works to help people imagine what a masonry wall might look like with a lot of different masonry colors and textures on it. And you might imagine that the Masonry Unit Database becomes a data repository for the Masonry Designer application. And this is a good time to remind you that we at Georgia Tech and in BIM-M in general are not developing software. We're developing the underlying technology to enable software. And so we want to work with our existing masonry software community. We're not developing new software that would compete against them. So here's just an example that Jeff Elder helped me with about masonry color. Jeff took 10 pictures of 10 bricks from his Atlas Copperstone line of large-scale masonry unit structural clay. And so these are 10 units, 10 images which represent the range of color represented in these units. So what we're encouraging you to do is to capture the full range of colors in a given line, a given SKU, and then we analyze this color using a color analysis tool from Martin Krasinski, and so it comes up with the red, green, blue values and the hue saturation values, and so according to Martin's analysis, this brick comes across as a dark drab red. That's not meant to be an insult. That's just the way the color turned out. And we can imagine a color range as well. Okay, is that me? Finally, we're getting away from the physical properties of units and talk a little bit about the properties in the database which describe you, that is the material manufacturer and supplier. So clearly, we want the database to tie the properties of the units to the people who sell the units, and that's you. So we will have the information in the database about you, the manufacturer of the units, where you are, how to contact with you, and based on where the person using the database is, you might not sell the units directly. You might work with a supplier in that region, and so the appropriate contact might not be the manufacturer of the unit, but rather someone in your supply chain who actually sells it. And so we can link that as well in the database. Okay, I'm going to turn it back to Shani now to talk about the trial implementation of the Masonry Unit Database, which is really where we're headed for, let's say, the next 2 to 3 months of this project.
We are imagining this database at this point. We will have a front end that the users can interact with easily, and it has a back end, which is a database that stores all the information that it can be later, you can search the information in this database, and the website that we are imagining as a front end can show the results. So I just emphasize that this is a very simplified version of this, the way that the front end and the back end can be created and work with each other. And we're imagining that we are going to have some sample units, around 60 units from the masonry unit suppliers in the working group, to input in the database to be tested actually by the manufacturers and also by the users. So we can upload the website that we have created online, so you can actually test it and then give us feedback. So if you imagine this database, this website, we have a front end for the website that is actually, this is where the manufacturer can input the information about their units. And on the back side, we have a relational database, in this case, an SQL database that stores all the information about different units that you have in this database. And later, the website also has a second page that is actually for the masonry users, so they can search with different criteria in the database and see what kind of units that is stored in the database. I will show you a demo of how the database can work. So this is the page for the input data for the database. It has different sections as the way that Russell described for you. We have some general unit information. We have the data for the manufacturer, what's the name of the company, and the address, and the contact information, and the website. You input all this information for your units, the database. At the second stage, you will move on to the materials that for this unit. You can add different type of material based on that specific unit that you're inputting the data for. The physical properties, that if you fill in as many attributes as you can, this will help the users, either the engineers or the architects, to find the units that is suitable for their need. With the texture information, what's the type of the texture, the name of the texture, the same way for the color. And you can also upload images that you have for this texture or image of the unit. And also for the masonry geometry, you can either choose it's a masonry, it's a clay unit, or it's a CMU unit. And when you input all this information, you can save it to the database. On the second page, now you can test and see that this unit that you just saved into the database, you can search based on different criteria, based on the role of the that you have. Are you an architect? Are you an engineer? Or based on different properties that here you can see for the unit that we just stored in the database, we have chosen color, texture, and material, and these are being shown on the search side of the website.
Thank you, Shani. I want to stress here that we see this website not as the way that the Masonry Unit Database will ultimately be implemented in the industry, but rather as a test bed, as a way for us to try the database out, and for you as masonry manufacturers to interact with the data and say, yes, this is what we need, or no, we need to have additional information shown. So it's a fairly simplified test bed that we can do at Georgia Tech as the industry is making up its mind who might ultimately host the Masonry Unit Database. So what are we at Georgia Tech doing next? We're going to be implementing the Masonry Unit Database with around 60 units, which we think is enough for you to try and see how the MUD is working. As Shani showed, we're already working on the front end and back end. We will update the database schema based on your feedback. So if there are additional attributes which you feel need to be represented in the database, then we can add those attributes. We're beginning conversations with software vendors that might want to host the database. These are companies like Autodesk with their Seek product, ARCAT, which is a very large repository of BIM and product information on the website. Smart BIM here in Atlanta has done work in the masonry industry with Oldcastle, I know with Jeff's company as well. So there are companies who are interested in using the Masonry Unit Database to drive their web portals for BIM information. And finally, we want to begin a discussion, or actually continue a discussion with our Masonry software community, including tradesmen, CAD blocks, masonry designer, because ultimately what we want to see is we want to see their software linked to the database so that it can automatically pull down the geometric attributes, that essentially anything that's in the database is automatically linked in with the software that many of you are already using today. And your feedback is really important. I can't overstress this, that only through listening to you and figuring out your business perspectives can we determine what goes in the database. And it's not just masonry suppliers, of course. As Shani showed earlier, we have a wide range of stakeholders throughout the life cycle of the masonry building project. So we're trying to present this work to all of you to find out. And so we're already making some modest changes to the data model based on feedback that we've received from you, and that will continue. How can you help? So we write a lot of reports. I know they're long and boring, but we ask you to read them and comment on them. The webinars like this one are ways for you to kind of get a quick snapshot of what we're doing. For masonry suppliers, I think that the Masonry Unit Database, in a sense, complements what you're already doing on your web pages, and it's another part of your strategy to get information in front of the people who buy your products. And you should be aware of these BIM portals. You should make yourself aware of them. We are not fully aware of where these industry-wide storehouses are going in terms of information, but architects and engineers are using the web ubiquitously to get information about products, and we in the masonry industry have to get with it to be up with other suppliers. If you want to speak with those of us here at Georgia Tech who are running this project, either in your company or one-on-one, please email myself or Chuck, and we're glad to set up a call with you. And as always, tell us what your problems are, because that's ultimately BIM-M as a whole is trying to address the kinds of problems and opportunities in the masonry industry that are arising because of all the information technology that we're using in design and construction. And so here's our contact information, myself and Chuck here at Georgia Tech. Jeff Elder. Jeff is responsible for what we're doing here at Tech. If you think we need better guidance from the industry or input from a larger cross-section of the industry, Jeff Elder is specifically in charge of our project, and of course David Biggs is in charge of BIM-M as a whole. And so that's it from here at Georgia Tech. Jeff, thanks for kicking us off, and we will stay online and answer questions.
The first is actually a comment that was given, and it said, we should include MVMA adhere stone. And I think that was referring to...
I'll let Jeff talk about that.
Okay.
You know, we definitely are planning on doing that. I mean, we're looking at all kinds of adhered masonry units. Stone will be one of them. The initial will be to use anchored masonry or structural masonry. That's how we'll start. But the intention is to go to a either manufactured veneers or both from concrete, clay units, cast stone units, regular stone units, cut stone units. So all of those are intended, but initially to get our feet on the ground and get something started, we chose whole masonry units in an anchored or a structural system.
Okay, our next question is, why is there a distinction between architectural and structural brick units, but there's no distinction for concrete masonry units?
Well, that's it's probably just an oversight. We haven't really dug into it. But if you look at the database itself, the database is intended to handle masonry veneers anchored, whether they're brick, clay, or concrete units, or even like Craft or some other material like that. I mean, we're not trying to be exclusive. We'll have all of those included, and they'll be part of the database. So there will be veneers as well as structural units in all materials if they're manufactured.
Okay.
Yeah, this is Russell. I'm going to follow up with Jeff's question and say that the kind of larger structural clay units are something that we at Georgia Tech don't understand as well. And we need a little more education, but sometimes we look at it as like a clay material with the CMU geometry. I know that's too simple, but we can easily make it more clear. But I would stress that both any kind of architectural block unit as well as a standard gray block unit in the CMU industry is fully represented in the database.
And we know that there will also be thin unit. I mean, there are thin units being made right now that are 1 inch or 1 1/4 inch faces that will be anchored. So those will also be included.
Okay, well, moving on to the next question. What was the rationale for having separate categories for architectural brick and structural brick? In theory, you could do the same thing for concrete brick.
Well, I think we just addressed that one. We recognize that what's designed as a veneer in a veneer category does not require cores or cells to line up. There's not a requirement for grout and reinforcing. Whereas in a structural, we need to be able to look at, these are load bearing. We recognize veneer units can be used in structural walls, but they're designed differently as collar joints or routed collars. And so this just helps us identify units. We talk about concrete. We're looking at structural concrete versus veneer, where we know there's 4/4-16s and 4/4-12s and 3 5/8 by 2 1/4 by 7 5/8 concrete units. So, like I said before, there needs to be a separation for their geometry and their use.
Yeah, again, this is Russell. I think it's the examples we showed today were the more conventional examples, but there's no reason that a unit that's made of concrete but that's shaped to be a face unit as opposed to a structural unit in concrete can't be shown in the database. It's fully capable of representing that. So all you would need to do as the masonry unit provider is put it in.
Okay, moving on to the next question. Is code compliance and reference included on a specific or general basis?
You want to talk about that, Russell?
Sure. Well, I think that what we do is that we represent not only the material property of the units, but what ASTM standards that those units might meet. And so in terms of code compliance, we're only talking about masonry units here. We're not talking about masonry systems in this project. So the best that we can do for code compliance is to say that this masonry unit meets ASTM C90. So if someone was to do a search and say, I'm looking for units that meet ASTM C90, then all of those would show up as a query into the database. I don't know if that helps answer the question, but that's the kind of information we're trying to include in the engineering properties section of the database.
The overall, overarching, when you start looking at the software development from, say, a structural engineering, where they need more information than that, and you're complying with, say, fire or structural requirements, seismic requirements, those will be input into the software at a larger, more global, rather than at this database for the unit.
Okay, moving on to the next question. Could you please clarify how you intend to incorporate regional information about suppliers and producers relative to units? Or is it that within the database, all locations where units are sourced will be captured?
Well, I think the intent initially is to provide. We recognize that there's opportunities for some manufacturers. They want to move product, excuse me, coast to coast. There are others that maybe are not interested in doing that. There may be issues where a product manufactured in one area really does not meet a severe weather requirement, we'll say. And so regionally, you would want to make sure that the product, if it needs to be severe weather and it has certain requirements in a certain market, that only products that would be that would meet those requirements would be available and be usable on the project. Now that doesn't mean you can't come in and set some other requirements, but initially that's what we're looking at is, can we identify whether this product is available regionally? It's, you know, it could be as much as saying, yes, this is available and here's the contacts, and but we're not trying to limit anybody from selling anywhere they want to sell. We want to just make it so that if you don't want it going there, you don't have to send it there, and if you do, you can say, yes, send it.
Right. This is Russell. I think that it's interesting. I have Chuck and Shani here, and they're on our database side. You could imagine saying that in the database we could have a list of zip codes or other regional characteristics, say names of states. And if you want us, this is important for us to listen to you, if you want us for you to provide a list of states that you provide to, then basically you can imagine that if the person querying the data model puts in a state where the project is and then queries the database, if you have limited your units to certain numbers of states, let's say you're a regional supplier, then those won't even show up for them when they do the query. And so listening to you, if that's important, then we have some modest changes to the data model that we need to make to facilitate that kind of regional filtering, if you will.
Okay, moving on to the next question. What sort of checks and balances will be in place verifying the information provided by producers, suppliers, relative to calculated properties such as thermal resistance, fire ratings, etc.?
So this is a huge question. I think the larger question is, you don't want to put junk in the database. You want the properties to be validated. And I think that is what I would hope is that the industry trade associations, let's say the National Concrete Masonry Association, if the database takes off, I would hope that they would provide guidance to their users and or an audit of the data in the MUD to make sure that it's representative. We can provide, and Shani on her interface already has able to check and make sure that certain properties are within a range that makes sense, so that your sound transmission coefficient isn't 4,000 psi or something silly that doesn't make sense. So we can make some quick checks to make sure to validate that your data is within a range, but we really have to rely on your expertise to make sure that the data is right. We certainly can't do that here at Georgia Tech.
Okay, moving on. What is the deadline for receiving feedback on the database?
Well, I don't think we have a hard deadline, but before we do this trial implementation, I think that we would like to hear from you within the next 6 weeks. And then if you can get to us within that first 6 weeks, your input can actually be implemented in the database trial. And we expect another round of feedback from you after the database trial begins, and at that point there may be even additional opportunities for feedback. So we're in a kind of a testing and response phase now, but let's say the answer to a simple question is 6 weeks.
Okay, moving on. Will you be considering stone products in the database?
Jeff?
Yes, the intent is, as I mentioned earlier, is to cover all of the products that would be associated with masonry. And so initially we were looking at it, does a mason contractor install this material? If the answer is yes, then we want to make sure that it's covered in our database.
Okay, then I think you may have answered the next question, which is, will structural tile be included?
Yes, and I would say it should be included because a mason contractor would install it.
Moving on. The hydrothermic and thermal mass properties performance is of increasing interest as in an ONRL's WUFI code, for instance. Are properties such as permeability, specific heat, etc. included or allowed for?
Okay, let me answer this. This is Russell. At this stage, we can only include properties of the units, not masonry assemblies, because the Masonry Unit Database is only about the block or the brick itself. So WUFI and other codes mentioned from Oak Ridge National Labs really compute on the properties of the whole wall assembly. The block, the backup system, the brick, the insulation, the vapor barrier. And so we will be considering this question that you ask really with the masonry wall model, which is just getting underway.
Okay, we have a few more questions left. Moving on. Will manufacturers be able to clarify what is stick inventory versus special order or stock, I think you meant to say, as well as lead times or those items?
This is a great question, and it went back to something that we stated earlier. I think that this is not an e-commerce database. So I think the problem that I have with answering that question, yes, is that starts to say that the database is facilitating a transaction between someone purchasing the masonry and someone supplying the masonry. And it's really not about that. The Masonry Unit Database is really about a repository of geometric and engineering and aesthetic properties to facilitate BIM and to facilitate people selecting your product. But I think the best the database can do is to get you, the masonry supplier, in contact with a potential client, and then you're going to have to speak to them about availability, price, minimum order quantity, and all that, because I'm fearful that if we put that information in the database, it will be something that causes friction between different people using the database. Let me put it that way.
Okay, moving on to the next question. What is the time frame for seeing the mud demonstration?
Well, the demonstration in terms of the web interface or however we choose to demonstrate this, and Shani is here, I don't want to get myself in trouble with her, I would say 2 to 3 months before you actually see a website or a URL where you can go and plink around with the database. We may be contracting with an outside company here at Georgia Tech to do some of this work for us, and so that's just a little bit up in the air.
Okay, moving on. If we don't want to publish some data in the database, how can we indicate we want the architect or user to contact us for that specific information?
That's something that we'll need to consider how that goes down. Obviously, by not putting something in, You make it more difficult for a designer to select a product because they have to make a call. So it's going to be, it's going to be your call. We do want to make sure that we don't tie every decision up. Obviously, like Russell was just saying, some things, availability, whether it's, when it can be produced, when it can be made, whether or not it's currently available, whether it's limited to certain times of the year, all those issues, it's just going to be more difficult for us to tie down. We want to make it, there may be something that you put in that says contact the manufacturer for availability. That certainly is going to be the case with every custom, every non-stock material would be some requirement to contact the manufacturer. So there's got to be some kind of check that allows you to reach out to that individual.
Okay.
Russell, comments?
No, I think that's right.
Okay, moving on to the next question. You didn't mention BIA in the beginning as a contributor. Is BIA contributing to Masonry BIM?
The answer is on a very small, limited basis, and that's why we're really reaching out to the manufacturers today. We recognize this to be one of the biggest undertakings that the masonry industry will have and will need to be involved in. It's really, I'll say it, but I think it's really short-sighted on the brick side not to be included. I think initially it's been recognized that the brick or BIA is supporting more of the residential, and that BIM is not really required for a residential type application. But if you look at the industry, I think it's probably maybe 30 to 40% commercial, the rest is residential. That would be brick usage in the United States. And so there is a lot, and a lot of the decisions that architects are making and owners are making right now about other material uses is a reflection of how easy it is to obtain that material, how difficult it is to get material on the job site, what happens when the material does get on the job site, and so on. And so it's important for our industry, and it's important for every single manufacturer to get behind it. As a manufacturer ourselves, we jumped on it. We wanted to make sure that we were involved because we see the future of clay masonry requiring, needing BIM, needing to be able to get in, make it easy for the architects and the engineers and designers to use this, make it easy for the owners to solve problems, do maintenance and other issues on our materials. So we're reaching out to the other manufacturers to get your buy-in. I looked at it and said, if we could get every dealer and every manufacturer to give $1,000, that would be easy to come up. There's got to be at least 100 of those, and I know there's many more. I believe there's 200 brick manufacturers in the U.S. If those would just give $1,000 a year, that would be 200,000. Currently, NCMA, I think, is doing 100,000 or plus a year, and I think that's what they're asking for. So it isn't a big request from our industry. We just need to do it.
Okay, moving on. Will Canada be separate or handled by regional availability?
I think Canada will be handled. There's going to be some other issues, some of the CSA requirements. Those will be, we're looking at Canada for their buy-in as well, so we imagine that they will come into this program, but there will be some regional differences, regional requirements that will make it slightly different. But the intent is to make this global to North America.
Right. This is Russell. I would point you to the BIM for Masonry website, and a most recent report on the Model Unit Database, Masonry Unit Database, is up on the BIM-M website. And there's a long discussion about the units of units. And when I say that, what are the metric and U.S. traditional units and the complexities associated with converting between them. To Jeff's point, we are anticipating that masonry units manufactured for the Canadian market and marketed with both dimensions and engineering properties in metric units will be supported in the database. We just have to be careful on how that's done.
Okay, moving on to the next question. Is there a database plan for masonry accessories?
Yes, it will be part of the overall BIM. Right now we're just looking at the masonry unit, but we know that there will be other materials connected to ours that will need to be specified, and so they will be linked in. And I think if you were to look at some of Russell's, did you get a chance to look at this over again and maybe dissect it? You'll see there's actually components there for the accessories that go with it, flashings and wall ties and vapor barriers and air barriers and so on.
Okay, the next item is a statement. He said that the BIM-M website has all reports, presentations, and webinars online for download.
Great.
Okay, moving on to the next question. Due to variability of raw materials, unit properties will change within a certain range. Will the mud use ranges or specific values?
This is Russell. I'm not a fan of ranges. I'll be honest. As a structural engineer, I think if you put a property in that's a range, it's not super helpful. I think that we have to address that. I think that we can add the complexity of a plus or minus to any engineering property, but I think we really have to think about how complex you want this database to be if we're going to be providing ranges of material properties for a given unit.
You know, the other thing about this, Russell, if I can interject, is,
of course,
for instance, ASTM already has range limitations for you. So if we're looking at certain materials and their properties, as long as you're complying with the requirements of those ranges, plus or minus in dimensions, absorptions, whatever that happens to be, we just need to make sure that we're meeting the minimum requirement or the maximum requirements when we put this information in the database. So if, for instance, we talk about cold water absorptions and your requirement is 0.78 and you say I'm 0.8 and that's outside, you're going to have some other number that says, okay, well, the cold water absorption was under 8%, or we did a 50 cycle freestyle if that was the current ASTM requirement, and we comply with that, so that as you go through the requirements, you can show that you're meeting the requirements as they go through. So I also agree. I mean, if you're needing an F'(M) for a structural masonry unit of 2,000 and you're giving 1,500, the manufacturer, or the engineer is going to look at it and say, well, I either design it for 1,500 or I get the 2,000. So I'm with you, Russell. I think we need to be more specific with our data. And granted, every product has mins and maxes that come out. And you don't make a clay brick, and every time you make it, you have the same exact IRA. But as long as it meets the kind of range, you put yourself in at whatever that mid-range is.
Right. And I'd follow up. I agree with Jeff, and I think, these are nominal properties that an engineer would use for a calculation, and we all know, for example, with compressive strength, that you're probably supplying a product that far exceeds the advertised value used for calculation. But if you have an F prime M, if you have a product that nets out to an F prime M of say 2,000, and you have another product that looks exactly the same, but it nets out to an F prime M of 4,000 psi, I would consider that a separate unit in the database, so that you have something that may look exactly the same, but if it's stronger, it's really a separate entry in the database. So you don't have to recreate the data over again. You just have another SKU for another product that has that higher strength, and that the user will see both your lower strength product and your higher strength product in the database.
Okay, and our last item is a statement. He says BIM-M has a symposium coming April 9th through 10th, 2015 in St. Louis. We hope to have the industry to turn out to see the progress on BIM-M for this and other projects.